Let's take a look at the cell membrane. The yellow spheres are the hydrophilic heads. There's two layers of them, and in the middle are the green hydrophobic tails. You'll also see here proteins embedded in the membrane. Those allow larger substances to pass into or out of the cell. If we zoom in and look at a basic two-dimensional view of the cell membrane, you'll see here the polymer beads represent the hydrophilic heads, and the toothpicks represent the hydrophobic tails. Think of the cell membrane as a very fluid and free-flowing substance. That's why we call it the fluid mosaic model. It's very flexible. The membrane allows certain substances into the cell. Here there's a higher concentration of the sprinkles on the outside of the cell, so they try to move into the cell. We call this going down the gradient. She didn't have to use any energy to swing downward. Just like these boats go downriver, they really don't need a lot of energy to move with the current. However, if you want to go against the current, you have to input energy. The cell has to use energy to pump from low concentration to high. Here you see little red dots representing particles wanting to get into the cell. They're too large to move through the membrane, so they have to go through the transport protein. Here you'll see another transport protein represented in pink. Here the little cubes move from the inside of the cell to the outside of the cell, moving from high to low concentration. Here's a good real-life example. Sugar has been placed on these peaches, and that sets up a situation where water wants to move from high to low concentration out of the peaches. So after just a few hours, water has gone out, and that's why you see all this juice in the bottom of the bowl. The cells in the peaches have lost water. Just as you can't get into events without a ticket, substances cannot easily get into the cell membrane unless they have a ticket, so to speak. If they don't belong in the cell, chances are the cell is not going to let those substances through the cell membrane. All living things require energy to perform their daily tasks. Here these girls are climbing a pirate ladder, and they're using their muscles and the energy in them to do it. Cells use two main organelles to accomplish this. Plants use chloroplasts to collect sunlight and make sugar, their food. Notice the tiny stacks of coins here that are used to collect the sunlight. Here are some chloroplasts as seen under a microscope. The little round green things are chloroplasts. Cells also use mitochondria. This mitochondria in here is used to turn food into energy. Notice all the folds that allow for more surface area for more energy to be produced. These plants use photosynthesis. They capture sunlight and turn the energy stored in that sunlight into stored food, such as sugar. It all comes down to ATP. ATP is the energy currency of the cell, so that animals can swim, pick up food, or do whatever task they need to accomplish. They do this by using mitochondria and chloroplasts.